Well, hello once again, everyone, and welcome to another Sun Devil Learning Lab lesson from Arizona State University. I'm your instructor, Michael Barker, and today we're going to continue with our work on fractions, and we're going to try and solve some multi-term fraction problems. Shouldn't be too difficult. I mean, we're just going to really use the skills that you've used before. We're going to strategize and solve multi-step word problems. And as usual, I'm going to go through my few notes that we have before we start. I'd like to make sure that you're in a comfortable setting with no distractions. By that I mean I want you to sit where you can do the best of your work and not be having to stop and start. The lesson will just take you longer. If you work somewhere, or if you can sit somewhere where you don't have little brothers or sisters pestering you, or dogs or other pets needing your attention, you'll just get through the lesson a lot quicker. Secondly, I'd like you to gather any supplies you might need today. You know, I'm going to suggest a couple of pencils. I really hope you've been keeping a notebook, and I tell you to keep the notebook all the time. In there, you could now, by now, have multiplication tables, a few other fact sheets that will help you make some of your problems a little bit simpler. You're also going to need several sheets of paper if you don't have a notebook. Scissors, only if you're going to make fraction bars or something. We've kind of gotten away from using our models that much, but a ruler would also be helpful as well, because when you do your worksheet, if you want to draw a number line, if you want to draw an area model, a ruler is always a really helpful tool in almost any math class. And then finally, be sure to use the restroom before we start. And remember that you can always pause the video if you need to take a break. You're not locked into this class in that sense. You can pause. And the other more important thing is, I want to emphasize, you can go back. If something doesn't make sense to you, go back, and hopefully it will make sense the second time you go through it. So I'm going to start with, we have some multi-term fractions, but we need to work on a little bit of a review sheet. And our review sheet is basically going to be just this problem sheet, where what we want to look at is, these should be pretty much intuitive to you now, I guess is the best word. Circle the smaller fraction, and then I want you to make larger units out of these fractions here. I'll give you a couple of minutes, take your time, and just try to fill in the worksheet as best you can. And welcome back. So now I'm going to submit my, my worksheet here. I'll get my picture out of the way. And again, you should have circled the smaller fractions, and you should have made larger units, which these answers, they could be a little bit of anything. For example, I'll tell you 2/4 could have been 4/8, but it also could have been 8/16. Okay? It could have, you can pick almost any fractions you want and fill them in there. Just make sure that they're equivalent. So if you have questions, you need to review what we've been going through, and another handy tool for that would be your multiplication chart. I'm not going to go through all the answers with you now. This slide is up here if you need to go back and confirm your work. What I'd like to do is do a little more review. And I'm looking at a little bit of a problem here, and it's 2/3 plus 1/5 plus 1/3 plus 1 4/5. What I'm hoping is that you can identify something about this problem. And what will happen is it'll make it a lot easier to solve, I believe. And that's right, we have like units. So let's combine them. We have 2/3 and 1/3. And we also have 1/5, and we have 4/5, 1 4/5. Even though we have a mixed number, as long as our fraction is a like unit, it's going to help us. So I'm going to ask you, what can you tell me about this problem? And I hope you know that we can take 2/3 and 1/3 and add those, and then we'll add them to 1/5 plus 1 4/5. One more step, 2/3 and 1/3. Hopefully that should be fairly easy for you to see. That's equivalent to 1. And 1/5 and 1 4/5. 1/5 and 4/5 is 1, and 1 and 1 should be 2. So our solution should be clear that it's 3. Again, if you need to review, or if this is giving you some trouble, then we need to go back and revisit a few of the previous lessons. So now let's see if the same works with subtraction. We did it with addition, but what do you think it's going to do when we work with subtraction? We have a problem, 5 7/8 minus 1/2 minus 7/8 minus 1 1/2. I hope you're already saying, hey, I've got some like units here, and I've got some like units with the 8s. And let's see how we would approach that problem. Exactly, like units again. So 5 7/8 minus 7/8, we can express that in the first part of the expression. And then we can say 1/2 plus 1 1/2, okay? And that's going to tell us that what do we have? We have 5, and we have 2, and we get a total of 3. Once again, like units again. Hopefully you can start making a connection, because what it'll do is it'll make a lot of your lessons and a lot of your worksheets a lot easier when you can make this connection. All right, let's look at our first our word problem today. It's going to ask us to think about a couple of things today, but it's not anything we're not used to. And we're going to use a lot of tools that we've used before. So as we work with our multi-term fractions, our problem number 1 is, for a large order, Mr. Magoo made 3/8 of a kilogram of fudge in his bakery. He got 1/6 of a kilogram from his sister's bakery. If he needs a total of 1 1/2 kilograms, how much more fudge does he need to make? So we're going to use our cubes method. I want to go back to that. Hopefully you remember it, but if not, let's talk about it. We circle our key numbers. I used red for our example. We underline the question. We want to know what they're asking us. So when we do that, I underline it and I highlight it, because on the computer, sometimes the underlining isn't enough. Then we box our action words. Are they asking us to add, subtract, multiply? We just want to know what we're going to do. We evaluate the steps we need to take, and then we solve and we check. Okay, we want to make sure our answer or our solution makes sense. So now we've circled what we know. We've circled he made 3/8 of a kilogram, and he got a 1/6 of a kilogram from his sister. So if he needs a total of 1 1/2 kilo, how much more fudge does he need to make? So let's look at this and analyze. What do we know? We know that he has 3/8 and 1/6 kilograms of fudge. We also know he needs 1 1/2. So our next question is, how much more does he need to make? Well, he needs to make 1 1/2 kilograms minus what he already has. Now, I hope some of you aren't getting disturbed or put out by the fact that we're using kilograms. Kilograms are just a unit. It's part of the metric system, and it's not different from pounds and ounces, but it's just good to be familiar with the emphasis on like units. We're still working on all kilograms as far as when we add our units. As long as our units are the same, it doesn't matter whether we use pounds, kilograms, liters, milliliters, whatever we use, the important thing is that they're all the same. So let's look at how he solved the problem. He took 3/8 and 1/6. He knew what he had, and then he knew how much he had to make. So I wrote the solution out on my board, and it's how much Mr. Magoo has. He has 3/8 and 1/6. And what we need to recognize first is, what is our lowest common multiple? It's not 12, but it's 24. So 3/8, if we change 3/8 into 24ths, we have 9 24ths of a unit. And then if we want to change 1/6 and we multiply it by 4/4, we wind up with 4 24ths of a unit. So what have we figured out he has? He has 9 24ths and 4 24ths of a unit. So he has a total of 13 24ths units. But now here's the question. How much more fudge does he need to make? We haven't answered that question yet. We know how much he has, but we need to figure out how much more he needs to make. So our second problem would be, how much more does Mr. M need to make to meet his required quantity? So we know that he has, or he needs 1 1/2 kilograms, and he has 13 24ths kilogram. So again, hopefully we notice we don't have like units. So what do we have to do? Well, the first thing we do is, let's take our mixed number and change that into an improper fraction. So now we're looking at 3/2 minus 13 24ths parts, and we still need to find our lowest common multiple. But we've already determined that that's going to be 24. So 3/2 is what we have to change to 24ths. 3 times 12 will be 36. And then 2 times 12 gives us 24ths. We're now in position to subtract 36 24ths, and we're going to take away 13 24ths, the amount we already have. And what does that tell us he needs? He needs 23 24ths kilograms more to finish the order. So we can write that Mr. M needs to make 23 24ths kilograms more fudge to finish his order. Hopefully you also recognize that 23 24ths is real close to 1, but it's not quite 1. So it just helps when we recognize which way we want to work when we simplify our fractions. So let's move on. We have another problem. And again, we're going to work in kilograms. Again, I hope that doesn't make anybody uncomfortable, but kilograms are the same as pounds, they're the same as ounces, feet. Everything is the same. It could be miles. This is just our unit. We want to make sure our unit is the same in all the expressions that we use. So John used 1 3/4 kilograms of salt to melt the ice on his sidewalk. He then used another 3 4/5 kilograms on this driveway. If he originally bought 10 kilograms of salt, how much salt does he have left? We can see him here dumping the salt, and it's an important question because you want to be sure and have enough for the next time, right? We're going to use our cubes method again. We'll circle our key numbers. We're going to underline what the question is. What are they asking us? Because at the end of the day, that's our bottom line. That's what we need to know. We'll box our action words. That's going to help us. And then we'll evaluate the steps we need to take, and we'll solve and check. So let's look. I've circled 1 3/4 kilograms of salt, 3 4/5 kilograms of salt. That's what we know that he's used. But he has 10 kilograms to start. So this whole problem has given us that much information, but yet it wants to know how much salt does he have left. I guess in case he has to put more salt on the driveway tomorrow. So I squared another and how much, because those are going to be our arithmetic problems. So let's move forward and see how we would solve a conundrum like this. What we know, John used 1 3/4 kilogram of salt plus 3 4/5 kilogram of salt. He also started with 10 kilograms of salt. So again, our question, how much does he have left? We should be able to figure this out fairly simply based on what we already know. And we could, if we have to, draw a tape diagram. The tape diagram will help us just illustrate it in our minds. He had 1 3/4 kilograms to start. He used another 3 4/5. And then we want to know what he has left out of our whole unit of 10 kilograms. So we set up an equation, right? We know that 10 is the whole amount, and we want to subtract what he already used. 1 3/4 plus 3 4/5 kilograms of salt. That's what he's already used. And what's that going to tell us? How much he still had left. And what did the math tell us? We should be able to do this numerically. 10 minus 1 3/4 plus 3 4/5 is the same as 10 minus 7/4. 1 3/4 is the same as 7/4. And 3 4/5 is the same as 19/5. Now I'm hoping you'll notice we still don't have a lowest common multiplier, but we know that it's 20. We can figure it out that it's 4 times 5 is 20, or we can do a multiplication chart if we need to. Hopefully with these lower numbers, you're still working without that you can recognize how to solve these problems. So, okay, let's look at what we have. We have 10 kilograms is what he started with. He's going to subtract 1 3/4 and 3 4/5. So he's going to subtract 7/4 and 19/5. That's our improper fractions. Let's go to our lowest common multiplier. He now still has his 10 total units, but he's going to subtract 35/20ths of a kilogram and 76/20ths of a kilogram. This is also where you may start feeling like you need to use a calculator when you solve problems with this method. So, and that's okay, but we know that 35/20ths and 76/20ths is a total of 111/20ths. So now we haven't really answered the question yet because we still want to know how much he has left. So 10 minus 111/20ths is going to be the same as, if we simplify, 10 and minus 5/11/20ths. And what do we have left? We have 4 9/20ths kilograms of salt left. And we can write that in a sentence too. John has 4 9/20ths kilograms of salt left. Hopefully the step process led you through that. You may have not done it exactly the same way, and that's okay, but we still want to wind up with the same conclusion, especially if we're going to be putting the salt out again tomorrow. And hopefully you grasp all those skills and abilities well, because now we're going to try a few word problems. I've got, I believe I have 4 problems here. Yes, we'll start with Number one, Sinister Stan stole 3 3/4 ounces of slime from Messy Molly, but his evil plans require 6 3/8 ounces of slime. He stole another 2 3/5 ounces from Rude Ralph. How much more slime does Sinister Stan need for his evil plan? Your second problem. Gavin had 20 minutes to do a 3-problem quiz. He spent 9 3/4 minutes on problem 1 and 3 4/5 minutes on problem 2. How much time did he have left for problem 3? And I'll give you 2 more. Mark's going to need 100 pounds of garden soil to finish his project in the yard. He finds 2 cases holding 24 3/4 pounds each in his shed, and a third case holding 19 3/8 pounds. How much more soil does he need? And finally, volunteers helped clean up 8.8 2/10 kilograms of trash in one neighborhood and 11.5 in another. They sent 1 1/4 kilograms to be recycled and threw the rest away. How many kilograms of trash did they throw away? I want you to take a few minutes and work on these. It'll probably take you 10, 12 minutes to complete the whole order, but come back if you want. I'm going to solve them one at a time. So if you want to work on them one at a time, that's fine. But if you also want to just do them all and then come back, that's good too. We'll be back shortly, and I'll start with our first solution. Well, hello again. We worked on our slime problem, I hope, and I hope you came up with something that looks a little bit like my worksheet. I started with what I know, and I know that he already had 3 3/4 ounces or 2 3/5 ounces of slime, but he needed a little more to get to his total of 6 3/8. Now, in this first problem, I thought it was okay to draw a tape diagram because what do we know? We know 3 3/4 and 2 3/5 are part of our whole of 6 3/8. So let's think about this. When we have our known whole and we have our other parts and we just want to solve for the part we don't know, what are we going to do? Hopefully you recognize from 2nd grade even that we should subtract. So 6 3/8 minus 3 3/4 and 2 3/5 is going to give us our solution to fill in our tape diagram. So let's subtract. We're going to subtract 6 3/8 minus 3 15/20 plus 2 12/20. I immediately went to the lowest common multiplier, and I hope that would be something that you're able to do as well. So when we solve this problem, we have 6 3/8 minus 15 or 5 and 27/20. This is our next part of the expression. So now we have, when we subtract 6, and we subtract 5 from 6, we have 1 3/8, and we still have our 27/20 left. So we have 1 3/8 minus 27/20. We can't work on that without having another lowest common multiple. And again, I didn't add it in. I hope you recognize that would be 40. If you need to use your chart, that would be fine, but 5 times 8 is 40, and 2 times 20 is 40. So 1 3/8 is going to become 1 15/40, and 27/20 will become 54/40. Now, because this is an improper or a mixed number, and we want to make an improper fraction, we can't subtract the way we're set up now. So 55/40, 40/40 plus 15/40 is 55/40, minus 54/40 gives us a final result of 1/40. And our answer is that Stan needs 1/40th of an ounce more of slime to conclude his evil plan. I hope that makes sense. If it doesn't, I think you need to go back and review some of the other sample problems that we've done. Let's move on to the next problem. Okay, Gavin had 20 minutes to do it problem 1 and 3 4/5 minutes on problem 2. How much time did he have left for problem 3? Well, how would we set that up? I went to the whiteboard. I knew that he had 20 minutes to do the whole problem. And what did he use already? He used 9 3/4, and he used 3 4/5. So we just don't know how much time he has left for that last question, but we can certainly figure it out. If we used a tape diagram, we would know he has 20 minutes overall. He's used 9 3/4 for our unknown quantity. So let's look over here how we set up an expression to solve this. We know 20 minus 9 3/4 plus 3 4/5. That is going to tell us how much time is left in the 20 minutes. But again, hopefully you can recognize that we need a common multiple. 4 and 5, I'm not going to keep writing the chart out or writing down the notes for you, because I think it's something that should be coming intuitive now. So 3/4 becomes 15/20, so we have 9 15/20, plus 3 and 16/20, 4/5 becomes 16/20. So now we have a situation where we have 20 minus 12 and 31/20. 12 and 31/20 is how much time has been spent altogether so far in the problem. So if we want to simplify, we should be able to tell the 12 and 31/20 is the same as 13 and 11/20, right? Because we know 20/20 is 1, and we don't want to be working with the improper fraction all day long. We're now working with a mixed number. 20 minus 13 and 11/20 is going to be 6 and 9/20. So we know that he had 6 and 9/20 minutes left. And if we want to check, we can reverse our process, right? We can say 9 3/4 plus 3 4/5 plus 6 and 9/20, our solution, should equal 20 if we did all our math right. So again, though, what do we need? We need our lowest common multiple. Again, 20. 9 3/4 becomes 9 and 15/20. 3 4/5 becomes 3 and 16/20. And 6 and 9/20 is already in the proper units. So when we add 9, 3, and 6, we wind up with 18. And when we add 15, 16, and 9, we wind up with 40/20. 40/20. 40/20, hopefully you can all recognize as 2. 18 plus 2 is 20. And we've now proved that our solution is correct. So he had 6 and 9/20 minutes left to finish the exam. Let's look at the next problem. Problem 3. We wanted to know how much fertilizer Mark was going to use. He found he needs 100 pounds of garden soil to finish his project. And he finds 2 cases holding 24 and 3/4 pounds each in a shed. So he has 2 of those. And he has a 3rd case holding 19 and 3/8 pounds. So he has 3 cases altogether. So we want to know how much more soil does he need to finish his garden project. So again, what do we know? I illustrated in my worksheet, he had 24 and 3/4 pounds, and he had another 24 and 3/4 pounds, and he had 19 and 3/8 pounds. So all we want to do is find out whatever this number here is for what he needs to make a balance of 100. So we know that if we subtract this total from 100, we should come up with our solution. I think the first thing we need to recognize is 24 and 3/4, and 24 and 3/4 is the same as 48 and 6/4. And we're still going to add our 19 and 3/8. So we've simplified the problem a little bit. We also know that 6/4 is an improper fraction. So we can change 48 and 6/4 into 49 and 1/2. So now we know it's 100 minus 49 and 1/2 plus 19 and 3/8. Okay, so now our next step is going to be to add our units into parentheses. So we know 49 and 19, and we're going to add 1/2 and 3/8. But when we go to add our 1/2 and 3/8, again, we know we need to change to a lowest common multiple. And what that's going to be is 8. 1/2 will be the equivalent of 4/8. So what happens? We wind up with an expression that says 100 minus 68, 49 plus 19, and then we still have to add our 7/8. So now we know that it's going to be 100 minus 68 and 7/8, and our simple solution should be 31 and 1/8. And what does this tell us? That Mark still needs 31 and 1/8 more pounds of garden soil. Your solution, whether you used if you used a tape diagram, if you used a picture model, whatever you used, as long as you came up with a solution of 31 and 1/8 more pounds of garden soil, you've done a good job. Okay, we had one more problem. We talked about volunteers helping to clean up 8 and 2.5 kilograms of trash in one neighborhood and 11.5 kilograms in another. They were only able to send 1.25 kilograms to be recycled, and they had to throw the rest away. So how many kilograms of trash did they throw away? I went to the whiteboard. And what did we know? We knew 8 and 2/10 kilograms of trash and 11.5 kilograms of trash is what they collected. But we have to remember that they were able to send 1.25 kilograms away to be recycled. So our question is, how many kilograms of trash did they throw away? Well, we know 8 and 2/10 and 11.5 is the same as 11 and 5/10. We want to have like units, but we still need to subtract our 1.25 kilograms that was recycled. So first, let's add 8 and 2/10 and 11 and 5/10. We have 19 and 7/10. We want to subtract the 1 and 1/4 kilograms that were recycled. So again, we have to look for lowest common multiplier. In this case, it's going to be 20. It's going to be 19 and 14/20, and we're going to subtract 1 and 5/20. Hopefully you made this connection, and if not, I want you to refer back to your multiplication table. But 19 minus 1 is 18, and 14 minus 5 is 9. So how much trash did they throw away? They threw away 18 and 9/20 kilograms of trash. They really didn't recycle very much, and that's something I think we have to work on as we go forward into our next few generations of sustainability. Another lesson for another day. I'd like to thank you for taking the time to participate in this lesson, and I hope it helps you move forward. It's repetitive a lot, I think, but hopefully you're starting to make the connections and lean back on your multiplication charts a little less, and it'll help you move forward as we advance into more complicated word problems and a little bit deeper understanding of adding fractions and the concept of where they come from. Thank you and have a good day.